Hey, Mayank. Yes,
Hey,
Yuri said he couldn't join, but I haven't seen Steve comment. He usually is pretty good at commenting that if he's not able to join, but I guess it's just two of us now. Were you able to do anything on the competition last week?
no, I was a bit occupied, so I wasn't able to do anything. But
Okay.
I looked at,
So,
yeah,
yeah, I was able to try just following, Chris Diott's um, notebook, and I can share my screen. I think I also posted in Slack, but I kind of started to add some things to the shared document. I believe you, Yuri, and Steve should all have access to this as well now.
yes, yes.
So, just posted on the two things that I thought were interesting and worth carrying forward. One is, what is this quadratic weighted kappa rank?
Mhm.
And that's kind of interesting because basically, I mean, to me, it's somewhat like, what was I going to say? Not classification metric. Suddenly, the thought skipped my brain of what I was planning to say in terms of what the metric. Oh, when two distributions are compared, it's like that. What's the loss we use when we compare two distributions? I kind of suddenly, the name of it escaped my
The
mind.
tail loss?
Yeah, tail divergence loss.
Yeah.
So that's comparing two distributions. In this case, it's more of comparing two distributions, but where the distributions are, in a sense, discrete and ordinal. That means that the order matters. That is, in this case, because we are ranking the essays, right, in an order, right, where one is kind of low and 6 is the best.
Okay.
So the point is that this metric penalizes you if your prediction says, for example, that a particular essay is ranked 2, if actual is 2 and you rank it 6, because the gap between 2 and 6 is 4. But it penalizes you more for that than if your actual was 2 and you ranked it as 1 or 3.
Okay.
So that's kind of the twist for this
Mm-hmm.
particular metric. So whenever you want, a metric where it compares two distributions, but the distribution that you are kind of trying to predict is as an ordinal and a rank value, so that there's the gap between 1 and 5 is supposed to be larger between, of course, it's actually numerically larger, but that's the point. The point is that, that 5 is a much better essay than 1. And if your prediction is a 2 or when an actual is a 1, then that's a little more acceptable than if the prediction were a 5 and the actual is a 1. So that's kind of what quadratic weighted kappa does. And then, there is a math, and I put the links of how people to calculate. But when you eventually understand it, then all you can do is you can just use the scikit-learn thing and set the weight to quadratic, and you have the relevant thing. And then the other thing, which, even though I've done many competitions by now, that I did not, I don't know whether you had seen this in other competitions and stuff, but this is something that I learned. So I thought it's worth capturing, which is if you're using a regression in this case, for example, we are classifying 1 through 6, right? So it could just be that you are just using it as a classification head on top of a debugger model, for example, and then you can just classify it into 6 classes. And the 6 classes can be 1 through 6, right? Like string 1 through 6. But what Chris does is use the mean square error loss and makes it into a regression problem. So it actually predicts a numerical value, but then obviously you clip it and you round it so that you get integer predictions. But the more interesting thing is that his point is he refers to another competition in which he had this common lit readability competition in which he had participated, and there is a discussion, if you click on the link I included, which says that, and this is the part I haven't still understood fully. I can give you the surface level explanation, but the detailed explanation, at least I haven't like completely internalized why. But the point of the discussion is to say that remove dropout from any regression related predictions, and especially in the layers where you do batch norm, because the discussion says that when you do dropout in the batch norm layers, then it tends to keep the mean the same but shift the variance, and this is the part that I'm still kind of not fully comprehending. So maybe you can go through it and we can discuss it again when Steve and you rejoin of what what is the what are the details. But it seems what the discussion says is, as it states here, the activations are scaled, right, because of dropout, but the variance is not preserved because the activations are scaled. And when you go through a nonlinear layer following this scaling, then a shift in the mean happens going into the final linear projection. And because of that, what happens is that the final projection, he says, fails at validation time and drop-off is switched off. Now, this is the part that I'm kind of still trying to grok. What does it mean to say that it will fail at validation time when dropout is switched off? But barring me understanding that, the net effect of it is that if you are doing regression, on top of some kind of a language model, then make sure that you remove dropout and batch norm because that tends to interfere with your actual prediction of regression values. And here's another paper where apparently they have kind of pointed this out. Now, what confuses me about this observation, and I haven't read this paper, I just kind of tried to read this particular link from Kaggle. But what confuses me somewhat about this is, I think at least my recollection is for many of the, like for example, even in the prior competition where we were using the spectral analysis and stuff, I thought we were still using dropout and batch norm and stuff in our network. So if that's the case, then why in this particular instance, is it more that when you're using regression, well, I mean, if you're using regression, you're using regression, right? There's no such thing as using regression in lieu of classification. I mean, as long as you're regressing, it's a continuous, I mean, what you're predicting is in a regression, a continuous value. I mean, you can always post-process it by clipping and rounding and stuff. But anyway, take a look at this and see whether you can add any more light to it. I just take away that it's better to zero out dropout in cases where you're using models for regression, but that doesn't jive with the traditional regression problems, for example, that we are using like even in the previous competition. But in this competition, for sure, if you look at the Chris Dior notebook, he goes in and zeroes out a couple of layers in the DiBerta network where they add dropout. So anyway,
Yeah, could you show that?
these are the two things.
They're using the DiBerta V3?
Yes.
Okay.
And let me see whether I can show you where. Yeah, we can pick this. So I ran both DiBerta V3 and V3X small because, the time duration to train, even if it is, well, I didn't exactly time extra small yet, but small takes about 6 hours to train. So that's almost already approaching the limit, right? Limit is like 8 hours or 9 hours at most. So, and that's even with a 2 T4 GPUs. And to the point of what I was talking to you about, the rest of it is fairly straightforward, except I did have a few questions and that I can ask and we can discuss. Otherwise, just using this notebook and submitting it. All this is fairly straightforward. The two things, I mean, he talks about all the things that he's doing in addition to standard DiBerta right here that you can go through. So all of them are fairly straightforward and simple explanation, except as I pointed out, remove dropout for regression is a key thing. He also doesn't seed everything, so allows for some level of randomness. And many changes the max length. 2024, I'm planning to, I think you can increase this to 1536. So I'm planning to run one run with 1536 and see whether it helps improve my score. But let me show you what I was.
Look, running this locally or on Colab?
I run it on Kaggle itself, but I am in the process of setting it up to run in Colab. Because when I want to run the base, here are all the DiBerta V3 models. And obviously he's using the small one. In this particular notebook, I copied and used the extra small one. And slide detour. Let me see whether I can find where my, that's not it. Anyway, I can maybe, here. So you can see that my small one gave me a score of 0.803. Of course, the top of the leaderboard is at about 0.822 now. And there are some public notebooks with some 0.82 score, which I haven't looked at yet. And the extra small is very close. You can see, it's like what, 0.009 less than this. But the reason he does this, and I agree, is, if you're trying to play with things, for example, if you are, like I said, increasing the token length and stuff, then you can kind of play with it at a smaller Tiberta model level, so you get results relatively quickly, and then apply it to the Tiberta V3 models, right? So that's this is the small one, but both are identical. But let me show you where here. The couple of other things he does is he adds a couple of tokens to the tokenizer, which apparently Tiberta removes, or Tiberta tokenizer removes, but since these are in our essays, this is essentially a paragraph, I believe, a new line, but I thought he was going to add 2 new lines, but anyway, yeah. And then a double space. So he adds those two to the tokenizer, and here is
Why
where
are they added here? The tokenizer, these new 2 new tokens here. Are
he
they
adds it.
specifically?
Yeah, he adds them because Tiberta apparently removes them, and they are there in the essays. So he wants to add them back. He talks about that.
Okay. The new paragraph and a double space.
Yeah. So where does he talk about it?
Yeah. On the
Actually,
4th line from the last, add new tokens.
yeah, because Tiberta removes new paragraph and double space from essay.
Yes.
So, and I was just going to show you that he also, you can see that he zeroes out the dropouts.
Mm-hmm.
And that's because if we are using the regression, then he zeroes them out. Otherwise, he doesn't. And of course, if he's using regression, then he needs to put the number of labels to 1 and then add, 1 plus whatever values to get the 1 to 6 range in the prediction. Otherwise, everything else is fairly simple as to what he's doing. In fact, see, if you use regression, you take the prediction. Prediction 0 is just predicting it's just the predictions, and then you do this prediction 0 round 0, which means basically you snap it to an integer and then add 1. And because you have learned, the other thing he does is he makes the labels when he's, here. So your score in the provided data set is actually the value between 1 and 6 for the essays, scored between 1 is low and 6 is high. And he creates the corresponding labels to be between 0 and 5 by doing this, right? And then if it's a regression, he treats the label as a float 32 value. If not, then it's classification. He just takes it as an integer value to predict. So you predict it as integers 0 to 5 or as a floating point value between 0 and 5. And because you need the predictions eventually to be between 1 and 6, not between 0 and 5, that's why he does where was it?
Between 1 and 5. Okay.
Between 0 and 5, because there are 6 values.
Mm-hmm.
So that's why he does this. So your prediction is going to be between 0 and 5, and then you want to make it between 1 and 6 by adding this, by snapping it to a whole value and then adding 1 to it. If you're using regression, this will obviously be a float. If you are using classification, then you use an argmax and just predict whatever the integer value is. So the rest of it is fairly simple. I mean, it's not very complicated, just using 5-fold. So then the question is, but interestingly, I believe many people have commented, I haven't also had the time to go through it in detail, is that while a debata base or a debata large gives you maybe a better score, sometimes actually it turns out that the score is not as good. Even if your validation score is better, your leaderboard score is worse, slightly worse. So that in itself is a problem, right? Like, a larger model doesn't get you a better result. So that's something else. I am curious how over time people are going to tackle that.
Mm-hmm.
But there are already some ideas. Chris himself is talking about, although I don't know whether he's implemented it, but he's talking about, how in this case he's using regression, but in the base notebook, he has the ability to set the flag and get a regression or a classification output. The other thing he's talking about is potentially using regression output and classification output and then combining them in some way. So don't have a flag which says if regression, well, I mean, you still have to do if regression, then do this, if classification, do this, but do both predictions. Come up with 2 sets of predictions, one regression and one classification, and then combine the 2 eventually to get average them somehow by voting or whatever to see whether that helps. Although I haven't seen an implementation, but I'm sure somebody would have probably done it. Anyway, so that's how far I am, but the leaderboard, let me see, is, like I said, the leaderboard is at 0.822, and this particular notebook, depending on your luck, gives you somewhere around 0.800. Mine was 803, but that's just sheer luck of the draw. About 822 is where the top guys are, but you can see that already there are public notebooks at about 0.82, even 0.819 and so on.
So how much memory does this take, this notebook that you ran? Do you have any inklings of that? Did it take full 16 gigs of VRAM or?
I don't quite know, but I don't think Kaggle has, unless you're using the TPU and stuff, I don't think Kaggle has a very large, it definitely doesn't support a 40 gig type of A100-ish capability. At most, it can, I don't even know whether it supports 16 gig. It probably runs out, because when I used to run, maybe it does 16. Have you tried with about 16 gig? I have not seen whether even 16 gig works.
Yeah, the P100s, I think so, 16 gigs, up to 16 gigs memory, or the T4s, you can use a dual T4s, 16 gigs
this
of
notebook
each.
uses a dual T4.
Okay.
So that is what is done by this notebook that I was walking through.
Mm.
But it's, just wanted to get going. And I believe what the top of these leaderboard guys have done is primarily combined Deberta with a light GPM on top. So it's still a Deberta based, and then you can see it says Deberta and light GPM, and then obviously instead of just using light GPM, you could try, cat boost and light boost and whatever else variants of gradient boosting machine that you want to use. So for example, this one again uses Deberta and LGPM and then a count vectorizer. So anyway, that's interesting stuff.
Yeah. I think Yuri said that he saw some people from San Diego Machine Learning Club and he wanted to send them here. He has replied in the chat. I think so. We
Yeah, I'll
didn't.
respond to that.
Okay.
Yeah, I saw that. I'll respond to it once we're done.
Okay. And just a quick note, you didn't put in the Zoom link here when you on the Slack. Yeah, here. So I missed that.
Oh, okay. Oh, I didn't. I forgot to copy and paste the link. Okay, I'll do that going forward. Yeah. Usually do that. In this case, since I was highlighting the competition, I thought strongly that I had included the link, I guess.
Yeah. But anyways, this competition is good, and there's a new one that started. I think so. The Ellipsis one, the chatbot
Yeah, that one is
a
kind of interesting too, but I'm
yeah.
going to see whether I'll have enough bandwidth to kind of do both, but I wanted to kind of continue to make progress on this one. And that one has a longer timeline too. I think it's in until July or something like that. So
It's May. The start date and August. August of 5th. The 5th
yeah, so it
August.
has
Yeah.
all the way to August. And I think this one ends in June or something. So there's good overlap. I think that one's just started yesterday, if I'm not mistaken. So that might
Yeah.
be an interesting one to also play around in. But we'll take a look at it and discuss whether anybody's interested in and have the time to do two of them in parallel. So we'll see. Okay, good deal. Anything else?
I think so. Going forward, what do you think are the uh uh upcoming things that we should focus on? We should be focusing on the Deberta way, the way Chris Stewart is doing with the AWQ. I think so, the metric, or should we be focusing on some other way of doing it? Because
I
people
think
are trying, yeah,
the
right now.
combination of Deberta and some kind of LGBM or basically some kind of gradient boosting seems to be the way that most people are going. I think Chris has also, if I'm not mistaken, attempted. Oh, the other thing is he also points to more data. This is another reason that I set it up on, that I'm trying to set it up on Colab, because I can use more data. Of course, I can also use more data on Kaggle itself. But, you start running, and that was one of the reasons I went to extra small to see if that runs faster, because you can see even currently with small, it trains for about 6 hours. So, and he's training 4 epochs, and each epoch is 15 minutes, 4 epoch is an hour, and there are 5 folds. And then, you do the validation in each instant, and that takes up 6 hours. And I think the max you have is like 8 hours and 9 hours. So you can add more data. The other thing, I think most people have commented that more data has helped him. The other thing which he has tried, and I haven't looked at what he has done, but he has also used the Mistral 7B model. I don't know how he has used it. Maybe we can look at it real quick. He's even published a notebook.
Cool.
Now the submission is very fast. Wow, for a 7 billion model, that's pretty cool. So this is a interesting stuff as well. So, you are asking about approaches. This is another slightly different approach. And yeah, I'm interested in kind of learning to fine tune these models. And, the other thing is whether you can use LoRa in fine tuning this model, because that will help reduce the time for fine tuning, if you will.
Mm-hmm. Yeah, of
So
course. I think so. With the Mistral, we can use LoRa. There are some automated Ludwig, like there's the Predibasis platform, Ludwig, that allows you to fine tune on Mistral and other Llama 3 for instance, or there are other uh, uh, frameworks for that stuff. So
yeah, but see, my thing is at least I'd like to restrict myself to Colab. That's where I have the compute, so I don't want to jump to another platform and then have to kind of port all the data and everything over and then port everything back and stuff. So I might just stick to Colab. And I've seen enough, I think, notebooks, PEFT, quantized LoRa. So it might just be a matter of slipping in a Mistral 7B model and then doing a PEFT quantized LoRa on the data using Colab notebook.
Yeah.
So I don't need all the other fancy platform stuff to do that. But
Okay.
that would be an interesting thing to do, because that will also enable me to learn about fine tuning using PEFT QLoRa.
Yeah, it's not that it's simple, straightforward in many instances. You can also use Xortal. It's a fine tuning library that's also being used nowadays. It's kind of like famous, and
What
people
is
are
the name
trying.
of it?
Xortal. I will share its.
Interesting.
It's from Open AI, from Open Access AI Collective.
Yeah, there are so many. Each of these little things is getting so many people, but eventually all of these things will consolidate, I think. Like, for example, right now, there are, at least 2 prominent frameworks for playing with language models, right? Like LangChain and Llama Index at a minimum. Those two seem to be the big guys. And then there's this whole plethora of vector store guys, Chroma and Pinecone and Chroma, and then there's Quadrant, I believe.
Yes, there
Those
is
are just
Quadrant.
2, 3 I know, but there are many, many more.
Yeah, I have used this Xhotel library in fine tuning Llama 270B on A6000s. So I had gotten access to that server a month back. I was in the CUDA mode.
What is the A6000? I mean, where does it stand with respect to like A100 and so on?
It has 48 gigs of memory. VRAM. Yes.
Doesn't an A100 also have like 40?
A100 has 40 and 80 gigs. But the efficiency is the same as the 4090s. So it's the same as 4090. Just the memory is 4090 has 24 gigs, but the A6000 has 40 gigs of
40,
VRAM.
not 48.
Yeah, 40.
You said 48 or 40?
48, sorry. 48. I got
so
mixed between.
A6000 is better in that sense than an A100?
Yeah, it's better than the 40 gigs one.
How about the H? I haven't seen H on Colab yet, H100. How much does that have, do you know?
H100 is the ADA generation one. It is better than A100s. It has approximately 2 times as performance. And all the Llama 3 and the latest models that are coming through the fee one from Microsoft are being trained on H100s.
Yeah, how much VRAM does that thing have, do you know?
80 gigs. It's the same as A100s.
But 2x that, right? 80, right? So 40
the performance is 2x that. Approximately 2x that. It's between 1.6 to 2x on certain benchmarks when you're trying to train. But yeah.
Yeah, by the way, the V3 model seems to be really good. I mean, and it's also open source, right? So the weights are all available and stuff.
Yeah. Take a look at this Xhotel library on GitHub, for example, from OpenAI Access Collective. I shared it in the chat. So it's a very good library for fine-tuning, and it's in active development. There's a Discord community too. So if you want to fine-tune specifically, and this is the best, I think so, at the current moment with respect to.
Does that mean is it installable on Colab and stuff and usable, or is it something?
Yes, it is installable.
Okay.
So on A100s, you can fine-tune the Llama 3 8 billion parameter model using Xhotel.
Okay, cool.
Using PEFT and stuff. You can also use a quantized version and using Unsloth. There's a unsloth.ai as a company too. They also put out notebooks for fine tuning. They fine tune the quantized version, the 4 bits of the 4-bit version of uh let me try. I just close some tabs, but This is it. So this is from, I think so, Onslaught. It's,
Mm.
yeah, uh, they tune in the 4-bit quantized versions, fine tune it. So you just have to use this Onslaught Llama 3 8B BNB. BNB here refers to the bits and bytes
Oh,
version
yeah. Yeah.
of from Tim determines. I think so. That's his name. Uh, so the original is in B float 16. So the
Mm.
B float 16 is in is quantized to this guy here. 4-bit one, and you can fine tune it on a 8 gig 8 gig VRAM GPU 2. So the maximum memory that it uses is 6 uh 6 or 5 gigs. So since it is quantized, so yeah, you can do that too. But
Interesting.
for,
Mm.
yeah, for a full one, I do not know what's the amount of memory. But on a A100, I think so you have 80 gigs, so you might be able to get away with anything. And you might just put it, you can download it, and download the model from Hugging Face, fine tune it using this LoRa, what they are using it here.
Mm,
And
mm, mm.
yeah, and you can.
Yeah, that's what I wanted to try is, like either use this Mistral 7B instruct or use um, Llama 3 7B or is it 8B, whatever
Mm-hmm.
the equivalent, and try using, he's just using the 7B baseline, right? And I wanted to kind of fine tune using best QLoRa, and
Mm-hmm.
because that will help reduce the memory size needed and the storage size on disk too.
Mm-hmm.
So
Yeah.
that'd be a cool thing to play with. Yeah. And if we have time, then if you said the other competition may be worth a look as well to see whether we can do both in parallel and whether some of the techniques are similar.
Yeah, since I'm working on RAGs a bit. So I was working on RAG with respect to uh uh your local deployment on my own hardware. So I was working on that. So yeah,
Yeah, but
uh,
what kind of GPU hardware do you have locally?
I have a 2078, 4 years old. Uh, it does not support B float 16 right now. Uh,
How much
so
memory does it have?
8 gigs, 8 gigs of RAM. So I was waiting to see when 5090 comes out, since it's right on the horizon right now. I was trying, I was striving to update to 4090, but I'm still waiting for 5090 to come out. I think so. It might be out in the next quarter. So I'm
How much
using,
would that have?
I think so, 24 or 30 gigs, depending upon what the uh, uh, thing is, what the size is, because the new GPUs that they have just come out with have 192 gigs GB of memory. So I was hoping they would increase that uh, a bit, but they also have support for 4-bit and 6-bit, at least in the uh, I think so, the B 200s that came out. The NVIDIA's Blackwell had
How
support
much do
for
those? How much is it a single board? How much does it cost? Do you know?
no, the cost has still not been revealed, but you can order it and it's like it's ranging from $30,000 to $40,000.
One
Uh,
card?
I think so. It's not one card. It's uh, a combination of DGX kind of a rack that has 8
Oh,
chips.
oh, so you're talking about some kind of server type configuration.
Yeah, so it's a kind of a server type configuration.
No, but I was asking about, like what you were talking, the whatever.
The consumer card.
Yeah, isn't that what you were thinking of buying?
Yeah,
How much does that cost?
that they haven't come out with it yet, since it's not
No, approximate range you anticipate.
uh, depending upon, since I think so, your RTX 4090 has a price of approximately 1,55,000. So I suppose 1,70,000 in India. And it's pure speculation right now. I don't know what
So
cost
somewhere in
will it.
the, I don't know, somewhere in the thousands, like 3,000, somewhere below $4,000.
Yeah, I don't know exactly what will the
And
price.
then do you basically have it on your desktop with
Yes,
with a CPU?
yeah.
How much does memory does the desktop have?
It has 32 gigs
Nice.
memory. Uh, so, but it also will have support for 4-bit or 6-bit.
Mm-hmm. So do you run Windows and WSL on it, or do you have like this Linux installed?
Full Linux in environment. I think so. I presented, and yesterday you were there. I saw your
Oh
name.
yeah, yeah, the RAG thing you were trying to
Yeah,
run on your stuff, right? Yeah, yeah, yeah.
yeah, with Llama 3. So that
Mm.
that that was my configuration. So
Yeah,
that's
I don't
that's
have
the
any graphics, so I completely run on Colab. That's my home for any stuff that I do. So,
yeah.
okie dokie. Thanks for the pointers, and we'll meet next week, hopefully with a few more people and see where we get to, and also whether we are interested in doing multiple competitions and stuff.
Yeah. And yeah, I think so with the quantized FP4 and FP6 coming out, with these Blackwell GPUs, I think so with the consumer cards, if they come out with it, so I will be running it directly on the quantized versions. So maybe even the 70 gigs one, the 70 gigs of the 70 billion Llama 3 can also run on my machine using some layers offloaded to the RAM. So people are running that too. So maybe that configuration also helps with some applications of RAG, or when you're trying to fine tune it. Or maybe it will help
Interesting.
in Kaggle too.
Yeah, interesting. Actually, the big advantage in Kaggle that I see is that disk is the disk thing is much larger, and you can attach, like, for example, you know, just the, we look at one of these, where is my, there. We look at this notebook. This is input. Okay, should we input? This Hugging Face Debutta V3 that I showed you, this alone is 12 gig. So, obviously, I mean, you don't need to load this in
extra
the
data set that he
Sorry?
is this the
Yeah,
extra data set?
There's not an extra data set. It's just all the Hugging Face models. Of course, you don't need to load all of them. You can just load the particular single one that you're interested in, but he just includes all of them. So, you can easily fit. But that's the thing with Kaggle, right? Like, adding this huge 12 gig data set is just like, oh, there is already somebody has built a data set, just import it and run. Whereas if you're doing this in Colab or anywhere else, this itself will, of course, it's not VRAM memory, but it will still take up your disk space. Of course, you can step around that by just, only downloading the model you need, which obviously is going to be much smaller than all of them put together, but all of them put together is 12 gig. There's so many Debutta V3s. I mean, in fact, all of these are Debutta V3s.
Yeah. These are all the versions of Debutta V3s, I suppose. Yeah. But you don't need them all. I think so. You can get away with loading a single piece of what you want right now.
Yeah.
But have you experimented with small and large and the base versions and which comes out on top?
I have just used small and extra small right now because I want to stay small and play with a lot of things, vary a bunch of things and see how they're doing. From the discussions, like I mentioned before, what people are saying is that base and large gives you marginal improvements, but large, in fact, gives you, in some cases, worse results than small or extra small.
Okay.
Base also doesn't guarantee that it gives you better results, which is the reason that I was saying there's some more work to be done to see, do we use more data? If you use more data with these larger models, does that give us a better results? And, things of that nature. Because right now, again, I'm talking from comments I've seen, I've not done it myself, but some commentary seems to say that, hey, while this improves your CV score, it doesn't improve your leaderboard score. Or it does but by very small amounts. And in case of base, and in fact, a worse performance in case of large.
Yeah. So we have the feature to fine tune on Kaggle too. So I think so we can do that and see if that helps in this competition or not. But does it requires internet? When you try to submit it, does it requires you to have the submission as off too? Internet as off. Okay.
Yes.
So we might have to fine tune it. Yeah.
But that shouldn't matter, right? Because once you get the model, it's only the inference of the test. So why would you care about the internet after you have fine-tuned the model?
So I was thinking of having a end-to-end workflow pipeline in which you can fine-tune and then submit it via inferencing. But we may have a two-part approach too, in which we can once fine-tune the model and then inference it using some other part and then submit it.
Yeah. Okay. Good
Okay.
deal. Thanks for joining and see you next week.
Yep. Take care. Bye.